Hello, this is Frederick from Tektronix. Today I'm gonna, not do a challenge, but I will go in through something I found out of one of our demo boards. So I'm sitting here, I have an MSO58 scope, which is a lovely user interface. It's the same as the MSO6 or the LP scope. So the user interface is different. There's some different hardware inside in terms of sample rate, etc. I will not cover any of this in this video. In this video, I will reveal something that it has been hidden for quite some time on our own demo boards and what's actually causing that effect. So I have a demo board and I have a little bit of a hopefully camera over here. I don't have anymore. Let's see here. So this is a demo board we're using. It has, yeah, I kind of like this one. I'm sorry that my other camera is not that great, but there's a lot of different signals that we get out of this demo board. We have everything from USB, Ethernet, and also we have one of the standard signal I use, which is showing some of the benefits of our scopes. It's called frequent or rare anomalies. And if you ever met the tech sales guys, I'm sure he showed you this. But inside this problem, this is, inside this signal is where I found something awkward. And this a little bit longer video will explain step by step how I did to figure this one out. So I think we're done there. So I will start. So we have channel 1. I will auto set. After that one is done, next step I will do, and I recommend people to do this as well, is that you can see we have an unstable signal. So what we need to do is looking at this one. So it's an edge trigger now. So we trigger at any of the edges. I need to have a hold off like 650 milliseconds. I'll go up here. We put it in normal. That's a good one. And time, and we put it at 650 nanoseconds. N, which means that we have a stable trigger. Now I can move this around and we can get rid of the cursors. We're going to use them later. So this is basically the first setup. And looking at this signal, one of the things you can do, try to find elusive event, is configure the view here and have an infinite persistence. So looking at this signal now, this is what we use in the demo. It's making sure that people understand that sometimes it's very good to actually see a problem before you try to trigger on it, because there's a lot of problem in this signal. It's actually 2 layers of problems. One layer is fine, and the other layer I'm not really sure what's going on. So let's continue. You can see that we actually capture one of those. You see it. It's kind of a glitch and a small run. So I just go and clear. What I can do instead here is using something called fast stack. And fast stack will tell you and show you this one, the same thing again, but much quicker. And one of the things you want to do here is kind of be an analog scope. So if you look down here, it's like 2-3 million acquisitions. And if I do a clear, I mean, it's pretty fast. It's a few 100,000 seconds. And if you go to the normal mode, of course, again, just to show you in this one, you can see 40, 50, 70, 80. It's a huge, difference. And some people, understand the value of this one to try to find an elusive event and then set up the triggers. Some cases they know the problem and they don't really care. But I like this function. It's very useful. So we go in here. And by the way, if you're not happy with the color coding tells you a little bit how frequent it is. The red is very frequent, as blue is not that frequent. But what I'm trying to do now, and I had some issues with this signal, because after running this for a certain amount of time, I realized there's something else going on. And you can see that on screen now, that seems to be something else. Not only the thing that we had from the beginning. So I will just make this a little bit bigger and we move it around. So look at this signal. This is how it should look like. Very nice, same kind of edge, and that's this little round. Here is also, what's this? I do clear again. So what I was thinking about is how we can actually trigger on this. And if you understand that we have kind of 2 similar pulse width and then the longer one. But look at this in here. What I'm doing now is I'm going to add the cursors again and trying to measure up here actually the width of the pulse. It's 175. And I'm just going to move my trigger up to that level, like here. So there's something that's triggering, something happens around 175 nanoseconds with this pulse. So let's try to trigger on it. And of course, one of the things I do now is 2 things. We probably don't need this infinite. I go back to auto. I really don't care about this one anymore. I passed that off. So we just have this one we can play with. And I put, everything is an auto, trigger is a normal. So now I go in and I do this, what I call a pulse width. So we set around 175. So I go for a pulse width, channel 1. I have a limit inside range. The maximum should be put it on 180 nanosecond. And the lowest should be 130 nanoseconds. And that should be a fine range of it. So let's see if we can capture something. This is a very elusive event. So hopefully when I'm talking here, nothing will happen. Ah, there we triggered. I'm going to move this a little bit out here so we can't capture that. So from time to time we have this very narrow pulse or something that is not okay. And the question is, where does it come from? And I think I know the answer. You can see in this case, we can actually go and measure now the pulse width. If we go up and measure, and we measure pulse width, positive pulse width, and you can see it's 124, and I can put this one up in not a histograms you should have, and not 2, I just removed it. We have one histogram, that's enough. And what I do in the histogram, this is a good thing for everybody to realize, that if you right click and configure, you use a logarithmic scale, otherwise the odd ones. And then of course we can just add a little bit more time here so we can capture more. You can see that it should be like hundreds and 200 pulse. We can go back to that later. But in this case we capture this really strange. So we have a lot of hundreds. There's another one with a lot of hundreds, and then we have this 180, which is one hit, and there's a lot of 200. The 180 is the off one. Okay, so how did I figure this one out? What is the next step here? So I thought, could it be a clock that's causing this? Because this is done by an FPGA, and there's a main clock, and there's a divider, and maybe there's some issue with the PLL settings, for somehow just randomly loses control over the PLL. It's not phase lock anymore, it just drifts around. So what I did, as I can try to show you, is I took one of the digital probes, just added it to the clock out, which is a 40 megahertz clock out. Sorry for it's not perfect, but this is what I did at least. And you can see, by the way, is this is how I run it. You can see on screen 2 places. So I'm going back. So what I did now is I have it on channel 8, so I will enable channel 8. And during channel 8, I'm only using one, which is the D1. So I will turn this one off, because I really don't care about those. And we call it clock. And here you can say we are already, oh, why is D7 up? Did I forget to have it? Oh, yeah, exactly, sorry for that. So we have this one. And what I would like to now is just take this measurement over here for the clock and just add it. And we want to measure the frequency. And we look at this and time trend. And it says empty input. Why does it say empty input? Trend division by 0, D0. This should be fine. And I will turn the cursors off. Is it because of the... We can actually go zoom in here. See what's going on. It should be fine. Frequency empty input. Oh, is that even possible? We're measuring, reference level. It should be 80-20 maybe. This is fine. Oh, it's a D0. You see, it's D0. Okay, delete measurement. Yeah, it should be D1. So let's make sure it's D1. No, it's D1. Channel D1. Okay, like this, and then frequency. Add it. Here we are. And now I can plot this as a time trend to see. And we unzoom and just look at it. And I think this reveals it. So we have this random pulses that I showed you in the beginning for us to capture elusive events. And for some reason, depending on where this kind of glitch is, you can see the frequency goes from 40 up to 50 and back again. It's just a, and this is the portion. It actually makes this one, this portion of our test signal too short. Let's just see if we can zoom in on this a little bit. So this is the start of it. So this is the short one. So we have one, 1, 2, 3, 4, 5. You can count. And suddenly here it's a little bit narrow. And the time we lose is because this is just, this is just a function of the clock. Of course, this pulse that comes very, very seldom will give you this very strange phenomena that, as from a demo board perspective, is even better than the original design. So just making sure that we have this in autoscale. Yeah, we have it. And the next thing I want to know is how often does it come? So if I go back to the acquisition here and just do stop and do a fast frame, and let's do 5 of them just to check, and then go back and do a single, I will capture 5 of these events single. It still says 0 here, so we just have to wait a bit. And when that's done, we will give us, how often does this occur? Meaning that somewhere in the line the clock has, dropped the PLL, something is spooky, and at the same time it happens on exactly that period of time. Now it's triggered once. I mean, it's completely random. So anyway, I think this is the end of this video. I hope you enjoyed it a little bit, and let's see if we can stay here for a while and just see what's happening. But now it's 2, 3. You see, random. So the basic principle that I did there, just to recap, I had a standard analog probe and I had a digital probe, which is an add-on. So you turn one of the analog channel into 8 digital channels. I put that down on the 40 megahertz clock, and then I measured the frequency of the clock, just a standard measurement tool, and plotted it. And what I'm trying to determine now is how rare are those events. I'm just pulling 5 of them just to check. And when I've done it, I will be able to see the worst spot and the and the best spot. So I can actually do it looking at, oh, here we are. So this is frame number 1, and this is frame number 2, and frame number 3. So if I measure the frequency here and click it to the maximum, this probably will be the shortest as well as the positive pulse width for the long one. And to conclude this one, I have a timestamp trend. So the first one is nothing, and then it's like 15 seconds, nothing, and then 25 seconds and 15 seconds. And I've done this over and over again. It's completely random where the clock actually hooks up, falls apart. And when it falls apart, it has an impact on the longest pulse. It's actually on the small pulse, but most impact on the longest pulse. So now we know it. I'm going to do a default setup, and we're going to just look at the signal original from the beginning again. So you can see here that we have a lot of edges around 180 nanoseconds. Should be like 100 and 200. So we go back, we do a default setup. Just to conclude this video, I do an auto set. I still remember that we had a hold off here for this one for 650 nanosecond. 650, I remember that one at least. And here it is. So we're going to measure this one. Measure. And we go for positive pulse width. Add. We went in here. And we go for a histogram. And we go for the logarithmic scale log. I mean, this is it. So I hope you get the point that try using a tool to reveal the signal and give you a lot of information. Thank you, and I hope you enjoyed this video.